are from Group 5.
We are going to present to you guys about our 50 project, which is
Seismic
Wave in Volcanoes.
Background of seismic wave in volcanoes. Seismic waves in volcanic region are produced by the movement of magma and the build-up of pressure within the earth. This internal movement can fracture surrounding rock and generate vibrations that are recorded as seismic wave. The presence of such wave often serves as an early warning sign of volcanic event like eruption of tremor. Therefore, monitoring seismic wave plays a critical role in predicting disaster and implementing early safety measures to minimize risk to human life and the environment. Firstly, what are seismic waves? Seismic waves are vibrations that travel through the earth, usually caused by earthquake or volcanic eruptions. In the case of volcanoes, these waves are produced when magma moves or when pressure builds up and causes rock to crack and explode. Let me explain some physics concept involved. Firstly is mechanical wave. Seismic waves are mechanical waves. This means they need a medium like rock or soil to travel through. Second is energy and momentum. During a volcanic eruption, a large amount of energy is released. This energy travels in the form of wave, and that's what causes the ground to shake. The third is wave speed. The speed of seismic wave depends on the type and density of material they pass through. In denser rock, the wave moves faster. The last one is reflections and refractions. When seismic waves move through different layers of the earth, they can be reflected or refracted. This helps scientists to study what beneath the surface.
Next, I would like to explain our methodology, which is how seismic waves are generated and studied during volcanic activity. Firstly, the movement of magma. The magma that is deep in the ground will rise upward due to the very high pressure. This causes it to push the rock around it. Secondly, the rock fracture. The pressure causes crack and break in the rock. The sudden release of energy produces small earthquake inside the volcano. Then, the release of seismic energy. When the rock breaks, the energy travels out as P wave, S wave, and surface wave. P wave are the fastest and can travel through both solid and liquids. S wave travels slower and only through solid, while surface wave travel along the Earth's surface and cause strong tremor. After that, the wave propagation. This will travel through the rock magma and rise to the surface. Next, the detection by a seismometer, which is an instrument that records of the strength and time of this wave. The data is shown as a seismogram. Finally, data analysis. Scientists will study the seismogram to identify the type of wave and find the source of activity. This allows scientists to compare the arrival time of P and S wave, and they can predict when a volcanic eruption will occur.
Based on our study from article, multi-layer modeling of waves generated by explosive subaqueous volcanic, several important findings emerged. First, Wave formation from subaqueous volcanic explosions is influenced by the eruption's energy, depth, and vent geometry. Essentially, stronger or shallower eruptions produce larger waves. Next point is Lake Taupo case study in New Zealand. When applied to a hypothetical eruption at Lake Taupo, New Zealand, the simulation showed that waves reach our shores within 50 minutes with maximum crest amplitudes around 0.11 meter for the nearest shore. Other than that, it is model performance. The multi-layer on hydrostatic model used in this study reproduced near-field wave characteristics such as amplitude, phase velocity, and more accurately than simply shallow water models, showing its effectiveness in predicting wave behavior. And finally, is wave-field behavior. Wave patterns can transition from oscillatory or normal wavy motions to solitary Taylor wave depending on non-linearity and dispersive parameters. This shows how the wave characteristic change under different eruptions on conditions. Analyzing this wave, scientists can understand what is happening deep inside the Earth, even before an eruption happens. The implications of this study are very important, especially for geological monitoring and public safety. Firstly, understanding seismic wave like PS and surface wave allows scientists to predict volcanic eruptions earlier and more accurately. When surface wave patterns become stronger or more frequent, it usually indicates magma is rising closer to the surface. Surface wave often cause the strongest shaking during volcanic tremors, so detecting them early helps give quick warnings to nearby communications. Secondly, this research helps us understand the internal structure of volcanoes. By studying how P and S wave travel through different underground layers and how surface wave behave near the surface, geologists can identify magma chambers, fractures, and underground pathways. So, this knowledge is vital for long-term volcanic hazard management and understanding Earth's internal processes. Finally, the findings supports the development and advanced technology. Improvement in seismometers, sensors, and AI-based monitors system depend on how well we understand different types of seismic wave. Better technology allows faster data collections and more accurate eruption predicts in the future. In conclusion, studying seismic wave, especially surface wave, which happens in surface, is not only about understanding volcanoes, but also about saving life, advancing technology, and protecting our planet. That's why, in geology, seismic monitoring remains one of the most powerful tools for volcanic research and disaster prevention.
Been preceded by several significant earthquakes and many small rock-breaking quakes, there's also a continuous release of seismic energy associated with the underground movement of magma. Volcanic tremor is a seismic vibration caused by the pulsing of pressurized magma and gas and can last for minutes or days. The seismogram is of longer duration and more continuous than rock-breaking earthquakes of the same amplitude. Earthquake swarms recorded by seismometers and the ground deformation monitored by tilt meters help scientists determine the location and depth of moving magma beneath the volcano, which in turn gives scientists information to issue hazard warnings.